Hey students, Professor Z here. Welcome back to another dazzling lesson in do-it-yourself off-grid retreat building. Again, this is going to be something that you're going to write up papers for at the end of every one of these lessons. There's 30 lessons, so you should have 30 pages of your own notes taken. I don't need to see them. You don't need to turn them in. Just go ahead and check that off your bachelor's degree program chart, and we'll give you full credit. And the reason why I don't need to see them is because of OPSEC, operational security. You keep them for yourself, but this should get you well on your way and get you started. And again, you need to know your own limitations and what you're able to take on, and your own clumsiness, and understand how athletic you are and able to walk up ladders and insert beams over your head. So all of these things need to be taken into account when you're actually taking on this project. So anyhow, let's get right into it. So this one is going to be the excavation of your hole. Have any of you ever thought about excavating your own hole for your off-grid retreat, your own home that you would be living in? I know a lot of people say that they're building their own home. I gave you my dedication video. I believe my Uncle Jay built his own home in Utah, but I don't know if he excavated the hole, poured his own footer, raised his own walls, and then did his own subfloor, raised his outside walls. I don't know where he started or stopped, but when people say that they built their own home, did they really build their own home from actually putting out their own stakes, excavating, and then building it right up to the roof and sealing it off from weather elements? So let's get into it. This is what we're going to be covering today. So tools and equipment: 100-foot tape measure, full-sized diesel-powered excavator with large bucket. I would go large with this, students. You're going to need 12-foot tape measure, chalk line, tool belt with ample supplies, orange or red spray paint depending on your colors, something bright, string, stakes, rake, shovel, pickaxe, wheelbarrow, laser, and proper attire. And your boots are going to get extremely muddy and dirty, especially if it's raining out. And make sure that you have clothing that is going to be able to not be mendable, repairable, and things that you will probably throw away at the end of this project. Step 1, planning the milestone. So this is very important, students. Most importantly, you have to find the correct spot and facing the correct direction that you want your home to be in. Remember, you have to also understand if you have roof solar panels, because if you do, you're going to want your house facing south, because that's going to give you the most sun for your solar panels. If you want non-roof solar panels and put them down on the ground as I did, you can build your house in any direction. So most people build their house south facing because that gives the most sun, but you could build it in any direction that you would want. So next, you're going to have to stake out your property properly. That was a tongue twister, wasn't it? You want to ensure that there's proper clearances around your home. Some codes require 20 feet from property boundaries to have structures, 50 feet. Remember that if you build close to your property line and you own, let's say, 100 acres, I really hate to say this, but in the upcoming videos I talk about my neighbors who are not your friends. You don't want your neighbors on your property. You don't want them to know that you even exist. But just remember, if you build within 100 feet of your property line, I can almost bet your neighbor who owns the same sized lot as you do, 100 acres, is going to build 100 feet from your house. So you both own 100 feet of property. You both own 100 acres of property, but yet you're now 100 feet from the property line, and you're going to be staring at your neighbor for the next 50 years, just 200 feet away. So be very cognizant of that. And then a quick tip here for you students. I did not do this, but I recommend it. You might want to live on your property for a year because get an RV or something. You need to understand wind currents. You need to understand weather patterns. You need to understand snow buildup. You also need to understand sun, because remember, when you install solar panels, there's a difference between sunlight and sun hours, which is used for electricity. And you may even want to build something facing more of the mountain range, or maybe down in one of your ravines where your one nosy neighbor is constantly looking at your house with high-powered binoculars from his house 4 miles away, but he has one of these celestial telescopes and he's staring right at you the whole time. That's actually happened to me, and it's still happening. But I've planted some cottonwood trees, and hopefully in the next 7 years they're going to grow pretty high. So, step 2, installing stakes. So you want to pull out your certified blueprints, and I've covered this in a number of lessons ahead, but make sure that you have an architect draw up blueprints, because all of the load-bearing walls and all of the gotchas would already be figured out, something that you don't have to do, one less stress off your shoulders. And if you're going to be building a project of this magnitude with this much time and treasure, you want somebody that knows what they're doing, already have designed a factual blueprint that you can actually stand on, pun intended, and build your house. So the other component of this is you want to make sure that your footer is measured out and it is squared. So this is a big warning. Step 3, square the perimeter. So for instance, if you have a 44-foot long home by 22 feet, look at my diagram here. I demonstrate how to use Pythagorean Theorem to do your calculation, and you must square both diagonal measurements and make sure that you come up with the exact number that's needed. And remember that you may have the correct length and width measured. However, it may be a rhombus. You might want to look that up, but it's kind of a slanted square, slanted rectangle. You want to ensure that not only is it the correct length by width, but also squared. So tip, for aid in this process of correct linear lengths, use the Pythagorean Theorem here, which is a squared plus b squared equals c squared. And you can only use this with 90-degree triangles, students. So if you don't have a 90 degree in your triangle, you cannot use Pythagorean Theorem. You're actually going to use another engineering term. I'm actually an electrical engineer by bachelor's degree, but the term is SOHCAHTOA if you don't have 90 degrees, and essentially it's sine equals opposite over hypotenuse, or it'd be cosine equals adjacent over hypotenuse, or its tangent equals opposite over adjacent. That's if you don't have a 90-degree right triangle. And I'll let you look that up. That's something I'm not going to teach in this lesson, but that'll be something for you. But you should have a 90-degree triangle, unless you got some fancy diagrams or something like that. You're building a hexagon or octagon or something. So from the diagram, you want to add a squared to b squared. And then what you're going to do is you're going to take the square root of that. And since it's 44 squared plus 22 squared, you're going to wind up with 49.19 feet. And that would be measured in both diagonal segments. Make sure you measure both. Now, in order to fix it, if it's off, you want to move one of the stakes closer or further apart until the two diagonal linear lines are now equal. And of course, they're going to measure, if you use my numbers, 49.19 feet. Okay? All right, tip. Spray paint solid line around the entire perimeter that you have staked out for your footer once it's squared. Then you're actually going to spray paint it an extra 2 feet on each side. And the reason for this is because you want to ensure that you can walk around the footer when it's dug out. Remember, your basement is going to be dug down, 4 feet deep, 8 feet deep, however deep you're going. And also, you need to spray paint solid lines because the treads on these excavators are larger than an Abrams Army tank. And you're going to sit pretty high up, by the way, and it's very hard to see around these treads. So if you have solid lines, I know people spray paint dashed lines. I recommend another tip is to use solid spray painted lines. So that way it's a lot easier from the excavator standpoint. All right, step 4, excavator basics. So the $1,000,000 question, students, is what to order in the selection of excavator. Well, order the $1,000,000 excavator. Okay, pun intended. I use the Link-Bout 210, which is very large. It's got 160 horsepower diesel engine, 48,000 pounds of pressure, and with hydraulic pumps, it's got a reach of about 20 feet, and it can crush stone 20 feet out when it's fully extended. So you want to make sure you get something that can do the job, and make sure that you have the requisite understanding of it. Now, the reason why I did it myself, because I wanted to do this entire project myself, and all of these videos will be me, Professor Z, doing everything. Even in the legal defense master's degree, I'm going to show you how to sight in your guns, how to do target practice, walk you through a handgun course. I even got a Navy SEAL water course where we're going to be shooting off of a Zodiac raft boat at targets on the shoreline. I got a pond on my property, so we've got a lot of do-it-yourself things coming up, to prepare you, for the future, and of course the apocalypse. As you've probably watched our videos on the website. So this is not being a crazy person, by the way. This is being very well defended and well provided for your family, in the effect of all threats that may come your way in the future. So, but one of the reasons why I did this was because it was $860 a day to do my own excavation, plus diesel. It came out to be about $1,000 per day. It took me 2 days, 16 hours total. And so for $2,000, I dug out my own basement. However, the lowest quote I had was $4,500, and the highest quote was $40,000 to do this. So be very careful. Warning, students. Your confidence factor must be there to do an accurate and professional job. Otherwise, pay somebody. Your entire home is resting on this spot, and you've got to get this right. Okay? Well, now that you're ready, there's two things you need to understand before you start excavating. First, determine where you place the fresh dug dirt. Remember, each bucket you take out, you don't want to move it twice. You don't have time for that. So you want to move dirt, and make sure you swing the boom out. You can get it, at least 10 feet away, but you can also go out to about 20 feet away if you raise the boom up in the air. And make sure that you are well outside the orange or red spray painted lines when you do remove dirt. Okay, and then secondly, you need to understand where the first bucket you're going to start with, because this was tricky for me. I didn't know whether to start in a corner or on the sides, but it must be exact. So what I did was I started in the center, but on the edge. So if you remember my diagram at 22 feet by 44 feet, I kind of started in the middle at the top of that rectangle, and then I started moving dirt out on both sides, and then moved myself left with the excavator, and then move myself right with the excavator until the actual rectangle is out. So, step 5, start digging. Warning, pay attention to your depth that you'll need to dig. If you dig too deep, you can severely jeopardize your project and actually create a severe debacle, students. You may not recover from it. You must have virgin soil as the base, because if you remove too much of a bucket and put it back, you've already lost the thousands of years of compaction in that spot by Mother Nature. And then, they do sell these things called the thumper, but they're kind of hard to use. And I used it in my footer trough, but it will pack it up to 90%, but you'll never get the 100% back. So you need to make sure that you don't go too deep. Otherwise, you're going to have a great debacle with your footer maybe cracking, your basement floor cracking. You could even have your house heave, snapping your subfloor, any tiles to your subfloor, and even your roof could crack and be torn down based on improper compaction of your footer. So step 6, fine-tuning. Once accurately programmed, there's these excavators that have the GPS on it so that the bucket does not go too deep. However, I did not have that luxury, only because I didn't have time to figure all this out, and I had to have the excavator back within 2 days. So what I did was I used a transit, which is a spinning laser, and then it also has a receiver hooked to a yardstick or 2x4, depending on how you want it to receive. And then you just walk around and you hear beeps, and the tones will be high. If they're fast, it means you're too high. If they're low, it means you're too low. And then if they're one steady tone, it means you're right on. So the transit worked good. Make sure you set it up in one corner of your basement, and then it should be above the hole, by the way. You don't want to put it inside, but you're going to walk around inside the basement hole with the receiver, and that'll tell you whether or not you are accurate. And then never move the transit, by the way. It should be in one spot all the time. Otherwise, you're not going to have a fully leveled floor. So, all right. And then in closing, be sure to click the thumbs up button below. You can subscribe to our channel. And then please go out to our website and drop us a $5 tax-deductible donation if you can at www.university1310.org. And we'll see you in the upcoming videos. Again, we got 30 of them, students, and I don't need to see your papers. Please keep those notes to yourself, and then just check it off on your bachelor's degree program for credit. All right, that's it. Godspeed.